In this video I will talk about survival-friendly methods to get unobtainable block states in Minecraft 1.12.2. So this includes command blocks, chain command blocks, repeat command blocks, structure blocks, structure void. So right here is like a structure void block. We can get water in Nether, we can get shrubs, like this is not a dead bush but a shrub. You can get petrified oak slabs, this doesn't burn. You can get seamless stone double slabs, seamless sandstone double slabs, seamless petrified oak double slab. Like I know it looks just like a usual plank of wood, but it's actually impossible in two different ways. Then there's punchable TNT, like if I punch this piece of TNT it ignites. Then there is all bark blocks. I should mention that we have pretty good setups for getting these first invalid block states, while the setup for these logs which have bark texture on all sides are not very good. Like you can get them, but you have to go our TV several hundred times. And other than that, we can also create some blocks which are not strictly unobtainable, but which you might want to create using these methods anyway, like end portal frame spawners, barrier blocks, end portals, end gateways, and if you have lost your dragon egg, then this is also a method to get your dragon egg back. Okay. Then I want to thank special thanks for to name for discovering the crucial bug which makes it possible. And other than that, this does require multi-threading. We need asynchronous observer lines, and in the video description I will link two videos, one by Earthcomputer and one by myself, explaining how you can get asynchronous observer lines in survival 1.12.2. In this video I will be using carpet mod and the carpet scheduling command and the carpet async beacon updates command in order to create the asynchronous observer lines, but it is possible to get these asynchronous observer lines in survival, so I will just use mods to make it easier, so I don't have to do a chunk swap for every contraption. So the first contraption right here combines water and anvils to create command blocks, and sometimes you get birch logs as an accidental byproduct. The way this works, firstly you need an async observer line, so in vanilla you need to perform a chunk swap to get this async observer line. And after that you just build this contraption in this specific location. Like it's very important that this contraption is in this location inside the chunk. Like if you move it to a different chunk it still works, but inside this chunk you cannot move over or want. And then you and then a lag spike will occur where we first create a bunch of anvil entities, and then you will hear anvil entities land, and then we will either get a command block or a birch log, or some of the observers in the asynchronous observer line will get stuck. So let's wait for the lag spike to finish. Okay, right here we got a log. Okay, it wasn't a birch log, but whether we got a birch log or a different log depends on the rotation of the anvil. Okay, but let's just try it again. So you can just flick this lever again to reset the contraption and put the anvil back here and try it again. So this time we got a log, but next time we'll get a command block. So let's see. Okay, let's see. Okay, and now this time we got a command block. And the reason you didn't see it instantly is that the async observer line makes it so that sometimes no packets get sent. So if you want to see the blocks, you have to right click them. So like the command block was there, but I only saw it after right click. To make it so that we can see all the packets, there's also another carpet rule which is called async packet update fix true, and then you can see the blocks immediately when they get placed, but that's actually not vanilla friendly. So like it doesn't modify the behavior of the contraption, but it will just make it so that we can see things. So the next contraption right here will combine fire with concrete powder to produce structure blocks, and sometimes as an accidental byproduct you get mossy cobblestone. So let me start up the async observer line. And the observer line blinks over here, and the contraption is over here, and right here we have a piece of concrete powder, and right here we have a dispenser with flint and steel in it, and it will use up quite a lot of flint and steel. And then what you need to do, you just need to flick this lever, and then a bunch of concrete powder entities will get created. After that you will hear the dispenser fire a bunch of times. It actually happens in a single game tick, but creates so much lag that you can actually hear like a time delay between the dispenser firings. And now we got a piece of mossy cobblestone. This time we got the accidental byproduct instead of the real thing. But we can just try it again. So let's place a piece of concrete there. Let's make sure that there's still flint and steel in there, because it does use up quite a lot of flint and steel. And then let's try to get a structure block again. This is again mossy cobblestone, so let's try again. The chance between mossy cobblestone and structure block should actually be 50-50. So like we need to, okay, and now we got it. Here's the structure block. So this produces a structure block. Next thing I want to show is water in the Nether, and to do this we of course want to go into the Nether. So in the Nether, and I've built up the contraption here. I should mention that for the contraption you need to have 256 different block states in the sub chunk. And in the overworld I was using some water, and then whenever I just replaced it by lava. So like it doesn't matter what precise blocks are in here, just the block states. The number of block states matter. Okay, let's fire up this contraption, try to produce some water. So here's the async line. And now you just flick this lever, and then you have a chance of getting some water. So let's see it. Create some anvil entities. And then you will hear some anvil entities land. And here we got the water. So right here you can see the water. And it can actually flow outwards. So if I destroy this block, then the water will actually be able to flow down here. And now you've got water in the Nether. And if you use this contraption, then it's very important that the anvil you place needs to face in the south direction. So if you look at the F3 screen, then you can see in which direction the anvil is facing. And you should make sure that the anvil is facing in the south direction, because otherwise the water block you will get will not be a source block. So right here we got a source block of water, but if you do it with an anvil which is facing in the wrong direction, or which is damaged, then you will get a water block which is not a source water block. And that's of course not what you want. You want of course to have a source water block. Yeah. But now you've got water in the Nether dimension. So next up we have a contraption which produces structure void. Structure void is a block with the small invisible hitbox right here, and as an item it looks like this. And you can produce structure voids by combining frosted ice with water. So let me start off the contraption right here. I need to turn on the scheduling. So right here we have async observer line, and right here we have the water, and now we will constantly freeze water and melt it again using armor stands with frostwalker boots. Oh, and we already got it. That was quick. Right here, right now, we have the structure void block right here. Next up, we have a contraption for producing seamless double slabs, like the seamless stone double slab, the seamless sandstone double slab, or the seamless petrified oak double slab, which looks kind of funky as an item. And the way you get these is by combining block 36 with a carpet. So what you do, you start the async observer line. And then you have a piston which pushes back and forth a bunch of carpet. And this one takes quite a bit of time, like you need to wait roughly 5 minutes, and then it will convert one of them into the double slab you want. So I will now wait for it to convert. Okay. Now you can see here that the cyan carpet converted into the smooth sandstone double slab. And if you took a different carpet, then you would get a different double slab. So the cyan carpet gives you this double sandstone double slab. The gray carpet, if it morphs into a different block, becomes a stone double slab, and the purple carpet becomes the petrified oak double slab. Yeah. And this is how it works. And like I will not wait for the other carpet to change, because it just takes too long for recording purposes. But if you do it yourself, it just takes roughly 5 minutes, and then you have it. Also, there are other recipes which use block 36. So, for example, if you combine block 36 with a piece of TNT and have a contraption like this, then you can get punchable TNT. And another thing is if you combine stained glass with air, then you can get the shrub. And over here I built a contraption which can produce shrubs, and the main difficulty with producing shrubs is actually that you don't destroy them after you produce them. So this is a contraption which you can fire by just flicking the lever after you put in the async observer line. then it will produce a shrub and then stop after producing the shrub, but it might also give you accidental byproducts which are wrong. So we can also get shrubs using this, but because it takes too long to wait 5 minutes for every of these, I will not show them. And other than that, you can also produce some blocks which you usually can already get by combining block 36 with terracotta. Like if you combine block 36 with green terracotta, you get end portal frames. If you combine it with brown terracotta, you get end portal. If you combine it with black terracotta, you get dragon eggs. So the construction would look like this. You have just the async line over here, and then the piston push back for some terracotta. And other than that, you also have a setup for creating spawners using block 36. So if you combine block 36 with mossy cobblestone, you can get a mob spawner. So these are all the setups which are based on pushing blocks. Then after that, we also got some setups which require some manual interaction. So all the setups I showed so far were automatic, and for other blocks you will need to do some manual stuff. So for example, if you want to get all bark blocks, what you need to do, you need to grow a tree and make it grow through leaves which have the check decay track set to 2, but the decayable tag set to false. So what you can, for example, do is you take an oak tree and you place some leaves above it, and you look at them. There are 3 screens currently. They have check decay false and decayable false, but if you place another leaf next to them and destroy the leaf, and then right click the leaves, then you see that the check decay tag comes true. And now the thing is, if you have an async observer line running while this tree grows through these leaves, then you have some chance of getting an all bark block. So if I grow this tree, and this has a low chance of giving you an all bark block, but you have to do it a few hundred times for it to work, and so I will not show it here, but it's definitely possible. And then other than that, there is also a setup for chain command blocks where you need to constantly replace fire by shulker boxes. This can in principle be done automatically, but I was too lazy to make a setup for it. But what you basically need to do, you need to always place a fire block, then dispense a shulker box into it, and then destroy the shulker box again. And you can automate that if you want. I was too lazy for it. And if you do it in precisely this location while observer lines are blinking over here, then you can get a chain command block. Then next up we got the repeat command block. You can get the repeat command block if you convert grass into grass paths while there's an async line running. This one actually isn't too bad. I think I will show this one. So what you need to do, you need to start up the async observer line. And then what you do is you grab a bunch of grass blocks. And you put a diamond shovel into your offhand. And what you now do is you go into survival mode, of course. And then you just hold right and left click. And then you will always convert it into grass and then mine it. And you have a small chance of getting a repeat command block when you convert into grass. So I will just stand here and wait until I actually got it. Okay, here we got it. We've got here the repeat command block, and we used up roughly 800 durability, so roughly 800 attempts, and then we got it. Yeah. So that's right here is the repeat command block. Other than that, we also have a setup for end gateways, which also combines frosted ice with water, just like with the structure void, except we do it in a different position. And this one is pretty quick, so I can show it. So right here, we do this, and if we just now wait a few seconds, it should turn into an end gateway. Okay, yeah, here we go. So now we've got an end gateway here. And right here, I'm using 10 armor stands with Frostwalker boots. If you use less armor stands, then it just takes longer, but it's basically the same thing. And also here, we've got a setup for barrier blocks, but I was too lazy to automate it. You can get barrier blocks if you dispense a downwards facing blue shulker box into 2 high tall grass. So basically what you need to do is you need to first use a dispenser to bone meal a piece of grass to get a grass block, then you bone meal it again to make it tall grass, and then you dispense a blue shulker box from above down into it, and then you can just use pistons to clear it up again. And if you do this long enough in this position while observers are blinking over here on an async thread, then you have a chance of getting the barrier block. And I leave it as an exercise to you to automate these setups. So let's now get to the actual explanation of how this stuff works. Okay, to understand how this bug works, we need to understand how block states are stored in Minecraft. The block states in Minecraft are stored in every subchunk in something called a palette. And the type of palette depends on how many block states are in the subchunk. There is the linear palette, which only exists if you have less than 16 block states in the subchunk. If you go above 17 block states, it changes to the hash map palette. And if you get more than 256 block states, you get the registry palette. And these palettes only downsize if you unload the chunk. So if you place like 256 blocks in a chunk and get the registry and then remove the blocks again, you will still have a registry, and it will only go back to the previous palettes if you reload the chunk. Now, to get the unobtainable block states, you need to have a registry palette. You cannot get them with other palettes. So before you build up the contraption, the first thing you need to do, you need to build 256 different block states in the subchunk in which you are performing the bug. And by a block state, I mean a block ID together with a data value. So each block ID only has 16 different data values. So in the registry palette for each block, it stores the block ID and the metadata. And it stores them in 13-bit numbers. And the first 9 bits of every 13-bit number will store the block ID within a binary. For example, if we have a command block, it has a block ID of 137. And if you write it down as a 9-bit binary number, then you get 0, 1, 0, 0, 0, 1, 0, 0, 1. So that's how 137 is written in binary with 9 digits. And then after that, we just add the metadata. So that actually depends on the orientation of a command block, but it just adds like 4 digits at the end, which tell you in which direction the command block is facing and whether it's a conditional command block or not. Okay. Now, if you have a registry palette, which you need to perform the bugs, then each block ID will be 13 bits long. The first 9 bits will be the actual block ID, and the last 4 bits will be the metadata of the block state. And these block IDs get stored in long array. So a long is a data value in Java which has 64 bits. And we basically have multiple longs, and the block IDs will get stored in the longs. But since the block IDs are only 13 bits long, every long will actually store multiple of the block IDs. Okay. And now, since 64 is not divisible by 13, there will actually be some positions where one block ID gets spread out between 2 different longs. So right here we could imagine that this green thing is the first long, and then the second long, and then the third long. And right here we have a block ID at position 0 is the first blue block here, and then the block ID at position x equals 1 would be the first block. So this would be x equals 1, y equals 0, z equals 0 in the subchunk. And if we then go to x equals 4, then we will have one block ID which gets partially stored in the first long, but which gets also partially stored in the second long. Now, what happens if the game actually sets a block at a position? When it sets a block at a position, for example, we could imagine that we set an anvil here, then what the game will do, it will read out the entire long, and then it will overwrite the part of the long where the position of the block is. So it will place a new value here, and then it will overwrite the whole long again. This happens if you place a block. Now, if you place a block in a position where the block ID is spread out over 2 different longs, then the game will first read out the first long. It will overwrite the part of the long where the block has been set with a part of a block ID, and will write it back to a first long. And then it will read out the second long and overwrite part of this long, and then store it back into the game. And now this can cause some problems if we have 2 threads acting at once, because if you have 2 threads acting at once, then we can get something called word tearing. So word tearing is something that can happen with multi-threading. If you have like non-atomic accesses, like you can also look it up on Wikipedia what word tearing is. But basically the idea is if we place an anvil here at the position where it gets stored in 2 longs, and then on a different thread start setting like maybe an observer in a different position which gets accessed by the same long, then what will happen is that both threads will overwrite their respective part of the long, and they will write, but the thread which writes later actually overwrites what the other thread did and resets what the other thread did. And then in this case, thread 1 will then write the second long, and as the end result, we will only have the second part of the block ID of the anvil, but we will actually not have the first part of the block ID of the anvil, because the set block of the observer will actually reset it completely, and this means that we now have a completely new block ID, which in which case would be the block ID of a stone block. So in this case, the anvil would actually turn into a stone block if we just have async observer line blinking while we do this. So as an end result, this means that we now have new async crafting recipes where we can combine block IDs of different blocks. For example, if we have a water block in the world, and then we at a position where the first 4 bits get stored in one long, but the other 9 bits get stored in another long, then what we could do is that we have an anvil fall into the position of the water and replace the water by an anvil. But if we also have an async observer line blinking nearby and accessing the second part of a long, then this async observer line can reset the part of the anvil which overwrote the second part. And as a result, we can then combine the left 4 bits of the anvil with the right 9 bits of the water. And if we do this, then we get the block ID of our command block. And in this way, we can get a command block. Now, the waste condition for watering actually has a very low chance of occurring. You can't really increase the chance. So if you want to actually get that, you need to attempt it a few hundred times. So you need to have water and need to have an anvil fall into water a few hundred times while you have async observer lines blinking next to them. So right here, I've marked out some positions in the subchunk where block positions get stored in 2 different longs. Now I should explain that this is completely independent of a y coordinate. So if you go up and stay in the same subchunk, then it will also be there like that in the next level. So like the phenomenon doesn't depend on the y coordinate, so you can go up and down as much as you want, while the x and z coordinate are important. And right here at the orange block, we have a position where a block ID gets stored in 2 different longs and it cuts off 1 of the bits. And over here we have a position where a block ID gets stored in 2 different longs, where 2 bits are in like one of the longs and the other 11 bits are in the other long. And this basically just goes around here all the time. And what this basically means is that if you have some async observer lines linking over here, and then maybe replace the sign by a different block, then you can get some kind of word tearing where the last 2 bits of a sign would get cut off if you have observers linking over here. Okay, I will quickly go over how the contraption for the command block works. So the first thing we need to do is we need to find the correct position where we mix the water and the anvil together inside the chunk, because what we want to do, we want to take the upper 2 bits from the anvil and the lower 11 bits from the water. And the position for cutting off the lower 11 bits of a block is right here at this blue bool. So this has x coordinate 9 and z coordinate 12 inside the subchunk. So we go over here to this x and z coordinate right here and then build up a contraption such that the anvil is at these correct x and z coordinates, and the y coordinates don't matter. Now we also need to figure out in which direction the observers are. In our case, we want to reset the lower bits, and for that you then want the observers to be in the negative x direction. If you want to reset the upper bits of set block state, then you want to have the observers in the positive x and z direction. But in our case, we want to convert, like we have an anvil replace a water block, and we want to have the higher bits of the anvil and the lower bits of the water, and then replace the observers in the negative x direction. So this is then the correct direction, and the observer lines will just blink over here, and the observer lines are like within the range where it writes to the same long as the first part of this block position. So the observers need to be within the 5 blocks from this position up to here. So like you can have observers up to here, and if you had them further away, then they would no longer be useful. So an observer over here wouldn't help, but observers here do help. But it's also important that the observers do have the same y position as the block where we want to create command blocks. So these observers actually need to be like at this height, and if you place them further down or further up, then they will not help to change the block at this position right here. Okay, so that's everything about the position. Now what happens if we flick the lever is the first thing that will happen is that this piston right here will schedule a block event, and it will retract, and after it retracts we will also update a bunch of observers over here, like we have an observer line over here. After the piston below the anvil has retracted, we will update the anvil with an observer line a lot of times, and this observer line will send out several hundred block updates because we have entire text on. This will make this anvil create several hundred fallen block entities. And after we have created all these entities, what we will do, we will use this geotick generator right here to push in this iron block directly below the anvil. And then the anvil will have a block underneath it, and then all of the anvil entities will get processed. And whenever one of the anvil entities gets processed, what it will do is it will delete the anvil and then the water will instantly flow into the space because it got updated and we have instant tiletics, and then the anvil entity will land again. And in this way, the water block gets directly replaced by an anvil, and then we have a chance of word tearing. And the important thing is that every single one of the several hundred entities which you created in here will do the thing. Like every following entity will delete the anvil and then it will land again. Then the next one can again delete the entity and land again. And each time we have an attempt to get a command block because each time we replace water by an anvil. Now I should also explain why we sometimes get the birch locks instead. The word tearing can happen not only when the water gets replaced by an anvil, but it can also happen when the anvil gets replaced by air. And if we get word tearing to happen while the anvil gets deleted and replaces itself by air, then we will get a lock instead, when the water can flow in there and then the anvil can no longer land, and then we have a lock instead. So what the contraption does several hundred times in a single game tick is it has an anvil, it deletes the anvil gets replaced by air, then water flows into a spot and the anvil lands again. And during each of these different set block states, we can get word tearing, and the two possible outcomes are here, command blocks and locks for the end result. So in the case of the anvil, if you create multiple hundred anvil entities inside the anvil and have a block below the anvil, each anvil entity will delete the anvil, and then water can flow in, and then the anvil entity will land again and will replace the water. And this can happen multiple hundred times in a single game tick. So you can basically make a contraption which guarantees to get to a word tearing inside a single game tick. It will just be laggy, but it is very fast. So there are not many blocks which can get obtained with gravity mixers, but for those blocks it's basically the best way. So you can get anvils and water combined will give you command blocks. If you combine concrete powder with fire, you can get the structure blocks. If you combine anvils with lava, you can get the water blocks in the Nether, and also if you combine dragon eggs with air, you can get end portal frames. And for these blocks, this is the fastest method. Now for other blocks, you can use piston mixers, because block 36 can turn into any movable block, and also pistons can turn any block into air just by pushing or pulling it. And for this reason, there are many possible crafting recipes which could involve pistons or block 36, because you can mix them together with any other blocks and then just have an automated system where you attempt it every 6 game ticks. And with this, you can get a lot of blocks. And for other stuff which you cannot get with piston mixers or gravity affected blocks mixers, you need to get creative. Like, for example, there are recipes for end gateways and for structure void, which use frosted ice and water. And there's a recipe for repeating command blocks where grass turns into grass paths. But in general, you might need to get creative on how you do the set blocks to actually do the word tearing. In the video description, I will also link a text document which Martha gave to me, which contains all the block IDs in their 13-bit binary form, how they get stored in the registry palette, and shows which block there are. So most of them are null because they're invalid block states. For example, if you have air, the only valid block state is the one which doesn't have metadata, and if you have air with metadata, it's not a valid block state. And now if we want to figure out recipes for any new block, then what we do, we can like search for like the specific block. For example, if we might want to get like the command block, and when we look at like the left bits of the command block, which is like 0, 1, 0, 0, and the right bits, then we need to find like blocks which combine together to produce the command block. So what we can then take is we take a few white bits of a command block and then look where we find any block which has these white bits. And then one thing we find is that, for example, water has the correct white bits for a command block, or a gold block would have the correct white bits for a command block, or whetstone ore, or melon stem. And then the next thing you need to do, you need to figure out whether you find any block which has the correct left bits. So if we go back to the command block and look at the left bits, it has then we have like here these left bits, and then you can also like go through the text file and see whether you find any blocks which have similar left bits. So for example, a beacon has similar left bits, or a cobblestone wall, or a flower pot. Now if you find some kind of contraption which can replace a flower pot by a gold block several hundred times in a game tick, then that would also be a good recipe for command blocks. But of course, most of the possible recipes are very infeasible, because turning flower pots into gold blocks is not really a thing that you can do with a single get block easily. And like the anvil and water is basically the best recipe for command blocks. And if you want to produce any blocks, you just need to find a way to merge the block IDs together. Yeah, and that's then everything for this video, I would say.